Hello everyone. In this video, we will look into the discriminant topic questions from 2023 question papers. Before that, let's revise some of the basics of the topic discriminant. So, what is discriminant? I hope all of you know the quadratic formula minus b plus or minus square root of b square minus 4ac divided by 2a. In this formula, the expression which is under the square root is called the discriminant. The discriminant tells us how many solutions the given quadratic will have. There are three options for the outcome of the discriminant. The first one is b square minus 4ac is greater than 0. Then the quadratic crosses the x-axis twice and it has two real and distinct roots. Next, b square minus 4ac equal to 0. Then the quadratic crosses the x-axis once. That means it has one real and repeated root. The third is b square minus 4ac is less than 0. Then the quadratic will not cross x-axis, so there will be no real roots. The solution is actually the point of intersection of the curve and the axis. If you are supposed to write the answer as an inequality, let us consider the case b square minus 4ac is greater than 0. So in this case, suppose say this is the point of intersection A and B, then you can write the solution as x is less than A and x is greater than B. This is the solution. The next case is b square minus 4ac is equal to 0. That means the curve touches the axis at one point. Then the solution is x equal to A. Then the third method is b square minus 4ac is less than 0. In this case, the curve does not cross the axis. So how to write the inequality then? So we have to assume it crosses the axis and we have to find the critical point A and B. And the solution is here between A and B. So you have to write x is less than, that is A is less than x and which is less than B. So in the first case, the root lies here, that is less than A and greater than B, but above the 0 line. Okay. Now the first question is from the question paper 12 FM 23. A line has equation y is equal to 3x minus 2k and a curve has equation y is equal to x squared minus kx plus 2, where k is a constant. Show that the line and the curve meet for all the values of k. So we have to prove the line and the curve meets. For that, first let us equate both the equations. Now bring all the terms into one side. You will get x square minus kx minus 3x plus 2 plus 2k equal to 0. So combine the like terms. minus x multiplied by k plus 3 plus 2 multiplied by 1 plus k equal to 0. So in order to prove that the line and the curve meets, let us find out b square minus 4ac from this quadratic expression. B square is k plus 3 the whole square minus 4 multiplied by a is 1 and c is 2 multiplied by 1 plus k. So let us expand this. We get k square plus 6k plus 9 minus 8 minus 8k. K square minus 2k plus 1. This can be written as k minus 1 the whole square. So we have to show that for all the values of k, the line and the curve meets. So now we got the expression k minus 1 the whole square. Okay. Now for k, whatever value you give, like negative or positive, whatever may be, you will get a positive value only, because k minus 1 the whole square, you will get only the positive value. That is b square minus 4ac is greater than 0, or it can be equal to 0 also. When k is 1, in that case you will get this is equal to 0. So k minus 1 the whole square is greater than or equal to 0 for all the values of k. Because it is greater than or equal to 0, that means it may have two solution or one solution, but it always meets. That means it always intersects. The next question is from the question paper 11 MJ23. The line with the equation y is equal to kx minus k, where k is a positive constant, is a tangent to the curve with equation y is equal to minus 1 over 2x. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. So first let us equate the equations. Kx minus k equal to minus 1 over 2x. Bring the x term, 2x term to the left hand side. You will get 2kx square minus 2kx equal to negative 1. 2kx square minus 2kx plus 1 equal to 0. So it's given this line is a tangent to the curve. That means b square minus 4ac is equal to 0 in this case. Tangent means it touches at only one point. So b square minus 4ac is equal to 0. So 4k square minus 4 multiplied by a is 2k and c is 1. This is equal to 0. This can be written as 4k square minus 8k equal to 0. We can take out 4k commonly. So k minus 2 equal to 0. So k is equal to 0 or k equal to 2. So k is given as a positive constant. So we will take the k value as 2. After finding the value of k, next we have to find the coordinates of the point where the tangent meets the curve. So we have to find out the point of contact. So when k is equal to 2, from this we can see 4x square minus 4x plus 1 equal to 0. Or this can be written as 2x minus 1 the whole square equal to 0. So 2x minus equal to 0 or x equal to 1 over 2. So after finding the value of x, next we have to find out the corresponding y value. When x equal to 1 over 2, y is equal to kx minus k, that is 2x minus 2. 2 multiplied by 1 over 2 minus 2, which is equal to negative 1. So 1 over 2 comma negative 1 are the point of intersection where the curve meets the tangent. The next question is express 4x square minus 24x plus p in the form a of x plus b the whole square plus c, where a, b and are integers and c is to be given in terms of the constant p. So first let us complete the square. 4 multiplied by x square minus 6x plus p. So minus 6x can be written as minus 2 multiplied by 3 multiplied by x. So from this we have to take 3. So 4 multiplied by x square minus 6x plus 3 square. We need to add and subtract 3 square. 3 square minus 3 square plus p. So this can be written as x minus 2, x minus 3 the whole square. So 4 multiplied by x minus 3 the whole square minus 3 square plus p. So this can be written as 4 multiplied by x minus 3 the whole square minus 3 square is 9. 9 multiplied by 4 is 36 plus p. So when you compare these two, we can say the value of a is 4, b is negative 3 and c is negative 36 plus p. B is negative 3 and c is p minus 36. The next part of the question is hence or otherwise find the set of values of p for which the equation 4x square minus 2x plus p is equal to has no real roots. So has no real roots means b square minus 4ac is less than 0. So b square minus 4ac is less than 0. Here b is negative 24. Negative 24 square minus 4 multiplied by a is 4 and c is p. This is less than 0. So 24 square is 576 minus 16p is less than 0, or this can be written as 36 minus p. If you divide both the side by 16, you'll get 36 minus p is less than 0. If this expression has to be less than 0, then p should be greater than 36. Then only you will get a negative value, that is less than 0. So we can write p is greater than 36. So set of values of p is greater than 36. The next question is, solve the equation 8x power 6 plus 215 x cube minus 27 equal to 0. So here the power is given as x power 6 and x power 3. Let us take t is equal to x power 3 and substitute this. Then we will get 8t square plus 215t minus 27 equal to 0. So let us use the quadratic formula to solve this equation. So t is equal to minus 215 plus or minus square root of 215 square minus 4 multiplied by 8 multiplied by negative 27. The whole thing divided by 2 multiplied by 8. So on simplification, we get t as 1 over 8 and negative 27. That is x cube equal to 1 over 8 or x cube equal to negative 27. So x equal to 1 over 2. Here x equal to negative 3.